Structure of the spine model. The MBS models of the lumbar spine consist of vertebrae L1 L5, os sacrum and os ilium. These bony parts are connected by joints with appropriate doof and ligament structures, which are attached to characteristic points of the skeletal parts. The facet joints are realized as three-dimensional, 3D, contact areas, so that the acting contact forces avoid the penetration of two corresponding joint surfaces. All the individual structures are modeled with specific material properties in order to simulate their realistic mechanical behavior. Surface generation. The 3D surface models of the vertebral bodies are based on computed tomography, CT, data sets of artificial vertebrae of Europeans. These data sets are generated through the use of segmentation and visualization plugins to visualize the data sets and make them available for simulation as computer-aided design, CAD, data sets. Surface generation through segmentation, left, and visualization, right, plugins. Modeling of the biomechanical behavior of the spinal structures. The surface models are extended to biomechanical models by adding specific biomechanical properties to all spinal structures. The biomechanical property of the translational movement of the intervertebral discs is described by a force law, which is composed of a geometry-based stiffness term and a damping term. Most movements of the intervertebral discs do not consist of purely translational movements but also of intervertebral rotations. If the disc is deflected from its initial position, a deflection-dependent reaction torque will be developed. As already said, in the model also the anterior and posterior longitudinal ligament, ALL/PLL, the ligamentum flavum, LF, the capsular ligament, CL, the interspinous ligament, ISL, the supraspinous ligament, SSL, as well as the intertransverse ligament, ITL, are implemented. Because a ligament can be defined only between 2 points, broad ligament structures are realized by a bundle of several fibers. The biomechanical properties of the ligaments are represented by characteristic curves of appropriate literature. In the following models, the facet joints are simulated by a 3D contact surface whose dimensions and orientation are directed to the inclinations of the facet joints of the surface model. In this way, the modeling considers the different individual dimensions and specific orientations of the facet joints in all lumbar levels. Is exclusively a detailed analysis of the load behavior of the facet joints in focus. The facet surfaces are simulated by a 3D layer of cartilage, see section 4. It should be noted that a detailed modeling of the facet surfaces is accompanied by a large increase of computation time. Therefore, prior to the model building a specific question should be defined, in order to decide whether such a detailed facet joint modeling is needed. A further important structure to stabilize the human body in upright position is the musculature. According to the 4 muscle groups, left and right musculus erector spinae and left and right rectus abdominis muscle, are modeled. The force representing the musculus erector spinae is varied so, that additional torque on the upper end plate of the vertebra L1 is no longer necessary to maintain the lumbar spine in a state of equilibrium. The model parameters used for muscles are taken from. These muscular structures are implemented at the moment just in the models of Chapter 4.1. A comparison of the different spine models with the corresponding muscle models is performed, see Section 4.